A lone spacecraft, no larger than a small car, continues its journey through the frozen frontier of the solar system. So distant now that the sun shines only as a faint star among thousands, Voyager 1 has been on the move for more than 4 decades, carrying with it humanity's curiosity and our message to the cosmos. Against all odds, it still speaks. And recently, its faint signal has delivered data that has left scientists astonished, offering new insight into a realm no human probe has ever crossed before. Voyager 1 has discovered a fiery hot zone in space, a region so energetic, so charged with invisible forces that it seems to defy everything we thought we knew about the cold, dark void beyond our solar system. But here's the mystery. There's no fire, there's no burning fuel, no flames, no familiar source of heat. Instead, Voyager 1's instruments detected an environment that is blazing with charged particles and intense energy, a place where the rules of our terrestrial experience simply don't apply. To understand the magnitude of this discovery, we need to travel back to the origins of Voyager 1's journey. Launched in September 1977, Voyager 1 was designed to study the outer planets, Jupiter, Saturn, and their moons. It accomplished these goals with spectacular success, sending back images and data that revolutionized our understanding of the solar system. But Voyager 1's true legacy began when it set course for the edges of the sun's influence, venturing where no spacecraft had gone before. The boundary Voyager 1 crossed is known as the heliopause, the outermost edge of the heliosphere, the vast bubble of charged particles blown by the solar wind. Beyond it lies interstellar space, a region filled with matter and radiation from other stars and cosmic events. It's here, far past the orbit of Pluto, that Voyager 1 encountered the unexpected hot zone. But what exactly did Voyager 1 find? Using its suite of scientific instruments, Voyager detected a region teeming with energetic particles, protons, electrons, and atomic nuclei moving at incredible speeds. The temperatures here, measured not in terms of heat you or I would feel, but in the energy of these particles, are astonishingly high. This fiery environment is a far cry from the icy emptiness we often imagine when we picture the outskirts of the solar system. This zone is not hot in the way a campfire or the surface of the sun is hot. Instead, it's filled with what scientists call plasma, a state of matter where atoms have been stripped of their electrons, creating a sea of positively charged ions and free electrons. In this region, plasma waves ripple through space, and cosmic rays, high-energy particles originating from outside the solar system, collide with the remnants of the solar wind. The result is a turbulent, energetic environment where the laws of classical physics are tested to their limits. The discovery was a surprise, even to the scientists who have spent their careers studying the outer solar system. They had expected a gradual transition from the solar wind-dominated heliosphere to the more tranquil interstellar medium. Instead, Voyager 1 found a boundary that is anything but peaceful, a dynamic, chaotic frontier where the sun's influence battles the forces of the galaxy itself. What causes this region to sizzle with invisible fire? The answer lies in one of the most fascinating interactions in all of astrophysics, the collision between the solar wind and the interstellar medium. The solar wind, a stream of charged particles ejected from the sun, travels outward at supersonic speeds until it meets the pressure of interstellar gas and magnetic fields. At this boundary, the solar wind slows down abruptly, heats up, and mixes with the incoming interstellar plasma. Here, Voyager 1's instruments recorded a dramatic increase in temperature. Not in the sense of air or surface heat, but in the energy of the particles themselves. These particles move at such extraordinary speeds that if you could somehow collect them in a container, the temperature would reach hundreds of thousands, even millions of degrees. Yet, because the density of particles is so low, far lower than the best vacuums on Earth, there is almost no sensation of warmth. It is, paradoxically, both unimaginably hot and incredibly cold. This discovery is more than a curiosity. It's a window into the fundamental processes that shape our solar system and our galaxy. The hot zone Voyager 1 encountered is a natural laboratory, a place where magnetic fields, shock waves, and cosmic rays interact in ways that help us understand not just our own corner of the universe, but the environments around distant stars, and even the origins of some of the most energetic particles in existence. For scientists, unraveling the mysteries of this region could answer questions that have puzzled astronomers for decades. How does the solar wind protect us from cosmic radiation? What happens to the sun's influence as it fades into the interstellar void? And what role do these energetic regions play in the larger galactic ecosystem? Voyager 1's journey and its discovery of a fiery hot zone without fire remind us that space is far from empty. It's an ocean of invisible forces filled with phenomena that challenge our understanding and ignite our curiosity. Even now, nearly 50 years after its launch, Voyager 1 continues to send back data from the ragged edge of the sun's reach, offering us a glimpse into the unknown and showing us that the universe is richer, stranger, and more dynamic than we ever imagined. As Voyager 1 pressed onward, it encountered a phenomenon that defied expectations, a region in the outermost boundary of our solar system where temperatures soared to hundreds of thousands of degrees Celsius. Yet, astonishingly, there was no fire, no crackling flames. Instead, what Voyager revealed was a realm sculpted by the invisible hand of charged particles and magnetic fields, a cosmic furnace without the familiar chemistry of combustion. This hot zone, found within the heliosheath, is the outer shell of the bubble carved out by the solar wind, our sun's constant outpouring of charged particles. Here, the solar wind slams into the thin soup of interstellar medium, creating a turbulent cauldron where temperatures climb far beyond what we experience even at the sun's surface. But in the vacuum of space, heat behaves differently. With so few particles present, the energy is trapped within individual ions, making the environment scorching in terms of particle energy, but not in any way that would feel hot to the touch. The Voyager team realized that this region is a frontier, where the influence of our sun gives way to the vastness of interstellar space. The spacecraft's instruments detected a dramatic increase in temperature, not from burning, but from the acceleration and compression of plasma as it collided with the interstellar wind. These are not the gentle breezes we know on Earth. Here, the solar wind is supersonic, and when it meets resistance, shock waves form, heating the sparse gas to astonishing temperatures. What Voyager uncovered was a cosmic shock front, a dynamic, ever-shifting border where our solar system's protective bubble is battered and reshaped by forces from the galaxy beyond. This discovery reshaped our understanding of the sun's reach and the nature of space itself. The heliosheath's turbulent, high-energy environment is a place where the rules of classical physics are tested against the extremes of astrophysics. To comprehend this region, scientists had to rethink how energy and matter interact when density is so low that collisions between particles are rare and magnetic fields dominate. As Voyager 1 transmitted streams of data back to Earth, it painted an intricate portrait of this boundary. Sensors measured the intensity and direction of magnetic fields, the composition and energy of incoming cosmic rays, and the subtle changes in particle density. They revealed that the hot zone is not uniform. Instead, it's a frothing, chaotic expanse, with eddies and knots of plasma swirling under the pressure of forces unleashed by both the sun and the galaxy. Each reading provided a new clue about the interplay of solar and interstellar environments, a cosmic dance that takes place on scales larger than the orbit of Pluto. One of the most captivating revelations was how the heliosheath acts as a shield. Within its turbulent borders, the solar wind slows and bends, forming a protective buffer that helps deflect dangerous cosmic radiation from reaching the inner solar system. Voyager's journey through this region allowed scientists to map the effectiveness of this shield and to understand how it fluctuates as the sun's activity rises and falls in its 11-year cycle. The spacecraft's steady stream of measurements showed that the boundary is not static. It breathes, expanding and contracting with the sun's magnetic moods. Voyager's passage through the heliosheath also answered a question that had puzzled scientists for decades. Where exactly does our solar system end? The answer, it turns out, is not a simple line in space, but a diffuse, shifting frontier. When Voyager 1 finally crossed the heliopause, the outermost edge of the sun's influence, it entered interstellar space and became humanity's first emissary to the galaxy beyond. The hot zone marked the last gasp of solar dominance, a place where the sun's voice fades and the interstellar medium takes over. Beyond the heliopause, Voyager's instruments detected a dramatic change in the environment. The density of charged particles jumped, and the direction of magnetic fields shifted. The spacecraft was now truly adrift among the stars, sampling the cosmic sea that fills the gaps between solar systems. Yet even here, the legacy of the hot zone lingered. The data collected from the heliosheath continues to inform models of how solar systems interact with their galactic neighborhoods, a crucial piece of the puzzle for understanding the habitability of planets and the survival of atmospheres over cosmic timescales. The fiery hot zone without fire, then, is more than just a curiosity. It's a natural laboratory, a place where the extremes of temperature, pressure, and radiation reveal the raw mechanics of the cosmos. Every bit of data that Voyager 1 beamed home through the vast void helped scientists refine their models of stellar winds, magnetic fields, and the architecture of our solar system's boundaries. The implications of these discoveries ripple outward. They shape our understanding of how stars and their planets are cocooned from the harshest elements of interstellar space. They inform the search for life, guiding astronomers as they peer into distant star systems and wonder, does a similar shield protect unknown worlds out there? And they remind us that, even in the cold, airless reaches far from any sun, the universe is alive with energy, structure, and dynamic change. Voyager's odyssey through the hot zone is a testament to the power of exploration and to the remarkable, often counterintuitive realities that await us in the frontier between stars. The spacecraft's instruments, designed and built decades ago, continue to function as sentinels at the edge of the known, capturing the whispers of an environment that no human has ever seen. This data does more than expand our knowledge. It prepares us for future journeys beyond the solar system, equipping the next generation of explorers with a deeper understanding of the cosmic ocean that surrounds us. The journey of Voyager 1, from Earthbound probe to interstellar messenger, is a story of persistence, ingenuity, and discovery. It charts a path that future spacecraft may one day follow, venturing even deeper into the interstellar medium, seeking answers to questions we have yet to imagine. And as we continue to receive signals from Voyager, we are reminded that the boundary between the known and the unknown is not a wall, but a horizon, one that beckons us ever onward into the heart of the galaxy. But what does it mean to truly cross into interstellar space? For Voyager 1, this milestone was more than just a change in scenery. The spacecraft began to encounter a region unlike anything we had seen before, a realm where the solar wind, that ever-present stream of charged particles from our sun, gives way to the raw environment of the galaxy itself. Here, Voyager's sensitive instruments detected a dramatic increase in cosmic rays, subatomic particles that have journeyed across unimaginable distances. The density of plasma surrounding the spacecraft also shifted, confirming that Voyager had left the sun's sphere of influence and entered a new domain. Then, in a remarkable discovery, Voyager 1 encountered what scientists come to call a fiery hot zone in space. At first, the phrase sounds paradoxical. How can there be fire where there is no atmosphere, no oxygen to feed a flame? Yet, Voyager's measurements revealed a region where charged particles, protons, electrons, and ions, were moving with astonishing energy. The temperature of this plasma, inferred from the speed and behavior of these particles, soared to hundreds of thousands of degrees. But there was no fire as we know it. In the vacuum of interstellar space, heat doesn't mean warmth you could feel on your skin, but rather the frenetic motion of particles zipping through the void at incredible speeds. This hot zone is not a static boundary. It's a turbulent frontier shaped by shock waves from supernovae and the restless breath of distant stars. Voyager's instruments, still remarkably functional after decades in the harshest conditions, mapped these changes in the environment, sending back data that challenged and refined our models of the interstellar medium. The spacecraft's plasma wave instrument, in particular, detected oscillations that hinted at the density and temperature of interstellar space, painting a dynamic picture of our galaxy's frontier. Voyager 1's journey, however, is far from over. Even now, it continues to transmit whispers from the edge of our solar system, each bit of data a precious clue about what lies beyond. Scientists eagerly await each transmission, sometimes waiting weeks for a single packet of information to traverse the vast gulf between the stars and our radio telescopes on Earth. These signals are faint, traveling over 24 billion kilometers, yet they carry the story of a spacecraft that refuses to be forgotten. The discoveries made by Voyager 1 have profound implications for future missions. As we design spacecraft to follow in its wake, whether to study the interstellar medium, search for habitable worlds around distant stars, or even embark on journeys to neighboring systems, the lessons learned from Voyager's Odyssey are invaluable. We now know that the boundary between our solar system and the galaxy is not a simple curtain, but a complex, shifting region of energetic particles and magnetic fields. Future explorers will need to contend with these challenges, armed with the data and experience that Voyager has provided. And let us not forget the human touch on this robotic emissary. Voyager 1 carries the golden record, a time capsule of Earth sounds, images, and greetings intended for any intelligent life that might one day encounter the spacecraft. It is a poignant reminder that even as we probe the technical mysteries of the cosmos, we are also reaching out, extending a message of curiosity and hope across the ages. As we look ahead, the legacy of Voyager 1 inspires both awe and ambition. We stand on the shoulders of the engineers, scientists, and visionaries who dared to send a spacecraft beyond the known, and we dream of the day when humanity itself may journey to the stars. The Voyager mission has shown us that the universe is not a silent void, but a place of astonishing activity and complexity waiting to be explored. With each passing year, Voyager 1 moves farther from home, yet it remains intimately connected to our quest for knowledge. Its discoveries challenge our preconceptions, fuel our imagination, and remind us that exploration is a journey without end. The fiery hot zones, the boundary-crossing data, and the persistent signal from the edge, all these are chapters in a story that continues to unfold. Thank you for joining us as we explored Voyager 1's incredible voyage into interstellar space and its groundbreaking discoveries. If you enjoyed this journey into the cosmos, make sure to like this video and subscribe for more content like this.